Okay, we're going to be working on section 3.6, which we're working on how do we solve some word problems that involve minimums and maximums. And what this video is going to be about is mostly a note sheet. And so it would really help if you had the 3.6 notes, min, max, word problems. And we're just going to go over how to complete that note sheet. And then my hope is that by having some sample problems, that then you can go and work out some of the word problems that are commonly found. So by the end, hopefully you're going to have to know a little bit more about how to solve a word problem where you're being asked to find a max or a min. So it's really when you're finding a maximum or a minimum function that you're trying to maximize or minimize. So we're starting here with this one. We have a rectangular garden. It wants to be enclosed by 3 sides by fencing. Now the thing is that one of the sides is the barn. And so here's my fence. I have 3 sides of my fence. 2 of the sides are going to be identical to each other because it's a rectangle. The third side is not guaranteed to be identical to the other 2 sides. Okay? And we want to know what's the largest area that can be enclosed, the largest garden that can be enclosed by 50 meters of fencing. And then we have a secondary question of what are the dimensions. It's going to be a what by what square plot or a rectangular plot. Okay, so the first step is to use the amount of fencing, in this case it's 50 meters, to write a y equals equation eventually. So what we know is that x plus the y has to add up to 50 meters. That's how much fencing we have. So in other words, 2 x's plus a y have to equal 50 meters. Now I want to have a y equals equation. Well, my y equals equation for this would be that y equals 50 minus 2x. So instead of the y that's here, I could put in here that really what we have is this amount right here, this side right here, is 50 minus 2x, that could be the distance of that side. Now we need to write an area equation. Now area usually equals the x times the y, or your 2 dimensions multiplied by each other. So in this case, I'm going to have my area be the x value, the first dimension, times the y value, but I'm going to use this to represent y, 50 minus 2x. And I'm going to multiply that out. I'm going to do the distributive property here, so I'm going to distribute out my multiplication. So 50 times x is 50x, x times negative 2x is negative 2x squared. My next step now will be that I need to find the first derivative of this area equation. I need to find a prime, okay? Well, the first derivative would be 50 minus 4x. Then I need to set this equal to 0, and then I always should have put here and solve. I don't know why I didn't say and solve. So I'm going to set it equal to 0, and then I need to solve it for what could x be. So if I added 4x to both sides here, I'd have that 50 equals 4x. If I divided both sides by 4, I'd say that x must equal 12.5. All right. We know then that this value has to be 12.5. And we can even calculate our y value, all right? And there's a couple different ways we can do that. One way is we can say, well, and really here we have to solve for the area. So I'll show you one way and I'll show you another way I could have gone about this. We have about 2 options right now. The first way to say, okay, my area formula above, from right up here, was that area was 50 times the x, and we found our x now to be 12.5, minus 2 times our x squared, 2 times 12.5 squared. If I plug that into my calculator, I get the answer of 312.5, and that's meters squared. I also, instead of doing it that way, could have gone back to my picture if I was a more visual person, and I said, well, I know that my one dimension is 12.5. This other dimension I know is 50 minus 2 times my first dimension. So I could have figured out that my other dimension was 25. And so then I could have said if I have a 12.5 meter by 25 meter plot of land, then the area is just whatever 12.5 is times 25. And of course, it's that 312.5 meters squared. I ran out of space here. So that's basically my answer to this problem. 2 different ways to solve the same problem. I answered both parts of the problem, which was the dimensions and what's that area. Okay? Let's look at another problem here. This one is a profit problem, probably one of the most popular types of problem of how do we increase our profit? How do we maximize our profit? It's really pretty important. In this case, we have a fruit grower, and he or she is wishing to ship early in the season when the prices are high and spoilage is low. I guess it is a he. He now has 15 tons on hand and estimates he can add 3 tons per week by waiting. His present profit is $300 per ton, and he estimates that it's going to go down by $20 per ton for each week he delays. In how many weeks, that's what we're looking for, should he ship in order to maximize his profit? So we're going to make W the number of weeks he waits. He should wait. All right, so we identified our variable. All right, and we did it in the other problem, the problem we just did by a picture. Here we did it with, it was easier to just do it with words. Write an expression for the amount. In other words, how much fruit does he have on hand? Well, he has 15 tons of fruit, and then every week he adds another 3 tons. So 3 times the number of weeks that we're going to go and we're going to wait. Add an equation or write an equation. And so that's its own expression, by the way. Write an expression. This should say expression, not equation. I just caught that. Write an expression for money. Well, my money, right now his price per ton is $300 per ton. And he's going to go down, that price is going to go down $20 per ton for every week he waits. So this is the tons, all right, and this is the price per ton. And our profit is the price per ton times the number of tons. So right now, all right, if he did it now, all right, if he said, okay, right now I'm going to sell. So now sell, his profit would be, he has 300, oh, excuse me, he has 15 tons, I apologize, and he gets a profit of $300 per ton. All right, so right now, he would have a profit of $4,500. But what happens if we get him to wait, and how long should we wait? And that's what we're going to talk about. Since profit is the amount times the money, we're going to write a profit formula. So our profit is going to be the amount, 15 plus 3W, times our money, 300 minus 20W, and that's what we want to maximize. Now again, we're going to have to do distributive property to see what this is when we multiply it out. We're going to see how it is as a function. So when I think of distributive property, I think I'm going to multiply these two together and those two. So a lot of people call this the FOIL, that they're going to multiply the first two values together, the outside values together, the inside, and the last. When I did that, I got 4,500 minus 300W plus 900W minus 60W squared. Simplifying or combining like terms, I got 4,500 plus 600W minus 60W squared. Now our process is find the first derivative of our profit equation. So in other words, I want to find P prime. I want to see what's the first derivative of this profit equation. Well, the first derivative of 4,500 is 0. The first derivative of 600W is just 600, and then we go minus 120W. We're going to set it equal, that's an and, sorry, and we're going to and solve. I forgot to put and solve in there. We're going to set this equal to 0, and we're going to solve it. So we're going to solve it for W. Adding 120 to both sides, 600 equals 120W. Dividing both sides by 120, I got that 5 is W. Well, what does that mean? That means you should, or our farmer here should wait 5 weeks. That's our advice as a mathematician. All right? Because in 5 weeks, what is the profit going to be? So here's my profit equation. The profit would be 4,500, all right, minus 600 times 5, minus 60 times, oops, sorry, this was a plus, by the way, minus 60 times 5 squared. And in the end, that profit turns out to be $6,000. All right, that's a little bit better than the 4,500. So he increased his profit by waiting the 5 weeks by $1,500. Pretty nice. All right. So having that, knowing the profit in the end, it wasn't asked this time, sometimes it is. What the answer to our equation is, was that our suggestion was that they wait 5 weeks, or that's our solution to this problem. This example, if a stone is tossed upward with an initial velocity of 112 feet per second from a height, and I apologize, I do have a mistake. It should be a height, not a heath, of 700 feet above the ground, above the surface of the Mars, sorry. Its height h above the surface t in seconds later is given by h equals negative 5.6 t squared plus 112 t plus 700. Determine the maximum height reached by the stone. So we have a stone, it's on Mars, it's getting thrown up, it goes to a high point and it comes back down. Now Mars has a different gravitational pull than the Earth does. So that's why we're kind of have a different maybe equation than you might have seen as far as solving some problems like this if you were on Earth. Well, this is the formula. This looks like a really complicated problem, but it's actually one of the easier ones because they give us the formula we're trying to maximize. What we have to do is just look at our formula given and find the first derivative. So we need to find the first derivative of h. Okay, so here, first derivative of h, 11.2, excuse me, it's a negative 11.2 t, and then we're going to have plus 112. All right, so that's our first derivative of h, and we set it equal to 0 and solve. I keep forgetting to put and solve. Okay, so we're going to solve it. So I'd say 112 then equals 11.2 t. We found t to be 10. So in other words, it takes 10 seconds for this ball to get to the highest point that it's getting. But they didn't ask me how long does it take. They said what's going to be the height at that point. Well, the height at that point is given by this equation. So in this equation, instead of the t, I just need to put in my 10. 112 times 10 plus 700. And in the end, it's 1,260 feet. Okay. Last problem. Let's see. I want to make sure I get to this. So here we have 3 numbers, and let's go through this. The third number is one that really isn't talked about. So I'm actually going to make my third number x. Then the second number here is the square of the third number. Oh, okay. The second number is the square of the third number. Then the first is the sum of the second and the third. Oh, okay, the first is the sum of the second and the third. And I know these can be tough just to know how to work these out. What we're trying to minimize in this case, not maximize, we're trying to maximize or minimize the sum of the 3 numbers. We want that to be a minimum. So here's the first number plus the second number plus the third number. That's what we're trying to minimize. Now if I combine like terms, it would be 2x squared plus 2x. First step, take the first derivative. Okay, 4x plus 2, set it equal to 0 and solve it. X would equal negative 1/2. Okay, now that we know that, we're going to go back here and say, okay, my first number, x is a negative 1/2. Means my second number would be negative or positive 1/4, 1/2 squared. And my third number would be 1/4, this plus the 1/2, the second and plus a negative 1/2, the second number and the third number added together. So here I end up getting a negative 1/4. So my answers in the end are the first number is a negative 1/4, the second number is a positive 1/4, and the third number is a negative 1/2. Those 3 numbers fit into the category shown by this. So this one's, I think, the toughest one, definitely, to kind of work out. It's hardest, I think, to write down your 3 equations here, or sometimes it's going to be 2 for you, but I think you just keep working at it and you'll kind of catch on. So there will be another video with some of the problems, the word problems, samples and worked out here and there, but this gives you a good idea and gives you a good note sheet of how to start.